Alright, let's look at an example of how we solve polynomial equations by the factoring techniques that we just looked at. So here we have a polynomial equation, 4x cubed plus 12x squared minus 9x minus 27 equals 0. So the first thing we have to ask ourselves, well, is there something that's common in here? And there's nothing in common in all of them. This 27 does not have an x, so we cannot factor out an x. If we were to try that, we can only factor out the x from these three terms and not from 27, and that would not help us. So we're going to see if we can group these together. So if we group the 4x cubed and 12x squared and minus 9x and minus 27 together, then we can see that we can take an x squared out from each one of them. And so we can also take a 4 out, because there's a 4 in here, and 4 also goes in 12 3 times. So if we do that, then we see that we can take out 4x squared, and what that would leave inside this parentheses for this binomial would be x plus 3. 4x times x is 4x cubed, 4x times 3 is 12x squared, which is right here. So what can we take out from minus 9x minus 27? Is there something that goes into both minus 9 and minus 27? Well, there is something. 9 goes into 9, 9 goes into 27, 3 times. So if I take out a minus 9, I can't take out an x because 27 doesn't have an x. So if I take out a 9, then I'm left with x plus 3 in here. Well, what I notice here is that I have an x plus 3 here and an x plus 3 here. So I can actually use the distributive property. And so this is as if x plus 3 was distributed into 4x squared minus 9. So I can group the 4x minus 9 together, 4x squared minus 9, and keep the x plus 3 the way it is. Because now if I were to multiply x plus 3 into 4x squared, I would get this right here, 4x squared times x plus 3. And if I were to multiply x plus 3 into minus 9, I would get x plus 3 times minus 9. So here now we have our factors. Alright, so we know that for x plus 3, multiplying a quantity and them both equal to 0, as we know that if two factors are multiplying each other to give us a 0, then each one of them have to be, they can be a 0. So x plus 3, that's easy for us. The answer here would be minus 3. We already know this. The answer here would be minus 3. Because if I plug in a minus 3, I get a 0, I'm done with this part. But what about 4x squared minus 9? What do I do here? What can I do here? Alright, so let's see. What we can see here is that 4 is a perfect square, x squared is a perfect square, 9 is a perfect square. So 4x squared minus 9 is like saying a squared minus b squared. That's what it looks like. Where a is 4x, where a is our 2x and b is 3, because 2x squared is 4x squared minus 3 squared is 9. So that's what this feels like if we had a difference of squares. So we can rewrite it as that. We can rewrite it as 2x minus 3 squared, because that actually gives us 4x squared minus 9. 2x minus 3 squared is 2x minus 3 times 2x plus 3. So we have 2x plus 3 times 2x minus 3 times x plus 3 equals 0. We already know that x plus 3 gives us a root of minus 3, but what about 2x plus 3 and 2x minus 3? Well, we set them both equal to 0. 2x plus 3 equals 0, 2x minus 3 equals 0, or x plus 3 equals 0. So here our answer is minus 3 over 2. Here our answer is positive 3 over 2. And here we already know that our answer is going to be minus 3. So we have three solutions: minus 3, minus 3 halves, and positive 3 halves. Let's take a few minutes to take these notes and ask questions.